Morning or good evening, everyone, depending on where you are in the time zones. And welcome to Cybersecurity Month here at exida. Today is the first in a series of webinars where we're looking at cybersecurity in particular. And today's webinar is going to be looking at the equipment evaluation from the end user perspective. So before we get into the webinar itself, I just wanted, for those of you who aren't familiar, sorry, I apologize. For some reason my microphone went remute, so I'll just rewind a little bit. I was just saying that this is Cybersecurity Month here at exida, and we're focusing on the end user today, especially from the point of view of the cybersecurity of the products being used in the existing controls networks or those that are being considered. I then was talking a little bit about exida. We're a global company. We specialize in functional safety, cybersecurity, both from the certification point of view and from the services point of view, and alarm management services. Together with that, we offer a range of software tools to help support, and we operate across a variety of industries. We operate in the automation, the automotive, nuclear, process industries, for example, the chemicals, refineries, upstream oil and gas, etc. And we can work with the manufacturers who supply products to those industries in terms of being able to provide management support for their functional safety or their cybersecurity in terms of policy development. We also can provide the certification and the tools to help support that. From the system designer point of view, the same thing. We can do functional safety management. We can also help them from the cybersecurity point of view and look at doing SIL verification for the safety side or alarm management and alarm rationalization. That applies also to the end users, where we can come in and do a gap analysis to the standards from the point of view of the 615.11 or the Cybersecurity 62443, which we're going to talk a little bit more about today, and provide a range of tools to support that. We can do risk assessments from not only from the safety point of view, but also from the cyber point of view. And in fact, one of my colleagues will be giving a webinar later this month on that particular subject. And we have some tools to support that. Engineering contractors, of course, they need to be able to show competency as well as being able to provide the expertise they need to support their customers, both from the safety and cyber point of view, and we can work with them too. We also have a very comprehensive competency program with our certified functional safety experts, and we will be shortly coming around to doing one for the cyber side of things too. Reference materials. We've actually authored a lot of books on automation safety and reliability, and we also have one of the main industry standard handbooks on equipment failure data, and also from the point of view of functional safety. So we have a wide range of reference materials, and also on our website too we have a lot of free information. If you go to the website, we have blogs, we have white papers, articles. These webinars we do are recorded and held for a year and then archived, so you can also find a lot of interesting topics and information. The goal here at exida is to try and educate and help people understand and be able to navigate through the standards that are out there for both safety and cyber and alarm. On the certification side, we are accredited by ANSI. We have A-class accredited for testing as well. So we can do product certification for 1508. We also do cybersecurity product certification. We can do ISA secure and Achilles level certification. We have an independent certification company, and as I said, we're accredited by ANSI. So we have a very good pedigree and track record. We've done the most product certifications in the world for 61508, and we're beginning to pick up on the cyber side of things too. It's interesting that cyber's probably where safety was about 12, 14 years ago. When the 1508 standard first came out, there weren't that many companies or manufacturers that had products that were certified to the safety standards. And so similarly with the IEC 62443 coming out, there aren't that many companies that have cyber certified products, but we expect to see that grow as the years go by and end users become more in tune with what they need in terms of the cyber side of things, and they will be pushing and insisting. So just a little bit about me. I've got 37 years of experience. I started off as an engineer, basically hardware software development engineer. I worked in control systems companies and safety. Many years designing safety equipment. Certified functional safety professional, member of the ISA, as well as Institute of Engineering and Technology and MBAs in England. And I've published managing risky projects as well as the conforming to 61511 operations and maintenance. I'm responsible for our end user business here at Exida, which includes cybersecurity as well as the functional safety side of things. So, enough about me, and let's talk about what we're going to do today. We're going to talk about the equipment cyber evaluation for the end user as a report card. This is a tool that Exida has developed mainly because of discussions we had with end users about how can they get an evaluation of the products they either have currently from the cyber security point of view, or for the systems that they're planning on developing. So we came up with a format which gives a very quick visual indication of how well a product can conform or comply with the standard. So what is it? Well, it's an objective evaluation of the cybersecurity robustness of a product. And in particular, what we're focusing on here is the IEC 62443-1-1. So we're looking at both embedded devices such as PLCs, logic solvers, and the like, and network devices such as firewalls or industrial security appliances, routers and switches, etc. And we attest the device's ability to withstand any cyber intrusion. So we do a couple of tests here. We're looking at the communications robustness and whether the product can survive network storms of various types, and looking overall at the cybersecurity landscape in terms of how vulnerable or how open is the product and also the system. So we're coming at it from that particular angle. I do apologize, I've got a slight cold, so if my voice crackles a little bit, that's the reason why. So what does it provide? Well, as I mentioned, it provides a very quick overview of a product's ability to meet the 62443 standard. And this, as you can see, we're using colors to indicate. So you can very quickly see that the red areas don't comply. Yellow areas will give some compliance to the standard, the particular test we're doing or the particular foundational requirement we're looking at. And green indicates full compliance. So what does the report card cover? Well, it covers the 7 foundational requirements that are listed in the 62443-1. Now these form the foundation for the system capability and security levels. We don't actually get into security levels here because right now the standard groups are still working on sorting out the security levels, including definitions and how to combine security levels to achieve a higher security level. So we're not looking at that particular aspect for the moment. But we do go through and we do look at the 7 foundational requirements. Even though the whole standard isn't released, we also include the drafts and to give the best possible snapshot and view of the product's ability to meet the requirements. So if we look at identification and authentication control, so this is where you're looking to identify and authenticate not just humans, not just the people, but also the software processes or applications that are running in the devices before allowing them access to the system. And here the goal is to protect the system by verifying that the identity of any user requesting access has the authority before activating the communication. And then use control, excuse me. This is where you enforce the assigned privileges of an authenticated user, whether it's a person or it's a software process or device, to perform the requested action on the system itself and to monitor the use of these privileges. So once the user is identified and authenticated, the control system has to restrict the allowed actions to the authorized use of the control system. So in other words, they can only get at what they're supposed to be able to get at, whether it's a person or whether it's a device or application. System integrity is to ensure that the integrity of the control system to prevent unauthorized manipulation. That was the problem with Stuxnet. Stuxnet allowed manipulation of the control system. So that's obviously something that has to be prevented. And of course, once the system is operational, then it behooves the end user to make sure they maintain the integrity of the system. Data confidentiality. Here you're looking to ensure that the confidentiality of information on the communication channels and in the data repositories are safe and they are not open to to unauthorized disclosure. So that's another issue that has to be looked at. Some control system generated information, whether it's at rest or it's being moved around the system, can be of a kind of confidential, sensitive nature. So this implies that some communication channels and data stores could require protection against eavesdropping and unauthorized access. And then timely response. Restricted data flow. This is where you basically segment the system through the zones and conduits. And you may recall that the fundamental is the strength in depth. So you make sure that you have well-defined network with identified zones or areas that you can restrict the flow of data to only the necessary level that you need to do. And this can also be done using unidirectional gateways, for example, or stateful firewalls, and the demilitarized zones, DMZs, to manage the flow of data. Timely response to events is in relation to, if you have a security violation, then you're obviously notifying the proper authority, reporting the needed evidence of the violation, and taking time to correct when incidents are discovered. Now this really comes down to how good are the policies, the security policies and procedures, and the lines of communication needed to respond. So those have to be well defined. And resource availability, here we're looking at ensuring the availability of the control system against the degradation or denial of essential services. Now, for example, if this was an SIS, a safety instrumented system, then the last thing you want is that you will lose your ability to fail safe, to actually perform the safety function. So that's a very important thing. So we cover those 7 areas. In addition to that, we also do the communications robustness testing, and then we look at the security development lifecycle. Security development lifecycle, how well has the product been designed from a cybersecurity point of view? And the essential thing here is it's not a pass or fail report, it's just giving an indication of how well the device meets the requirements of 62443. In essence, it provides you with a sort of a gap assessment in that respect. But it's a visual indication, and it's easy for the end users to see what's going on. So how is it done? Well, the device is subjected to a series of tests designed to reveal vulnerabilities, such as broadcast storms, unicast storms, incorrect protocols, ICMP messages, malformed packets corresponding to the protocol the device uses. So you can see here, in this example, this particular device, it was fine with the network, the Ethernet side of things, it was fine with that, but from the ICMP, the ARP, the IP, TCP and UDP testing, here where we're looking at the controls maintained or it was fail-safe, we can see these are all red, no's. So if this was part of an SIS, then this certainly would not be something that we would want to see, because it would give you a potentially dangerous situation. Even if it was a redundant system, if the software was the same in both and you had the same problem, then you would lose the redundancy in the case of this particular type of test. And normally we would do these types of testing on the shop floor or on a system that was offline. You wouldn't want to do these types of testing with systems that were online for obvious reasons. So in terms of what it tests from a common point of view, which is common to both the embedded devices and the network devices, you have the user authentication, as we already mentioned. That needs to be done. The data protection, how well is data protected, and of course the fail-safe capability, especially for a safety instrumented system application, if you're looking at the logic solver, for example. So here we would have a number of tests we would perform and look at to see, and then you would, the tool that we developed looks at combinations of certain things, hence you can get the colors coming up red or green. So again, it's an easy visual way of seeing how well does the product meet, in this particular case, the authentication requirement. So if we look at the embedded devices, here we're looking in particular at the ability to withstand the broadcast storms on its interfaces. A lot of modern PLCs now, or controllers, use Ethernet type IOs, or could have IOs distributed using either Ethernet or some form of communications network. And if it's not a proprietary communications network, then it's obviously going to be open to potential vulnerabilities. Even proprietary could be if there's backdoors left in the software, for example. But this is why we look at the ability to withstand these tests. If there's a wireless link, there could be a remote terminal, that could be another potential area, and any USB ports. So what you're looking at here is the ability to recover after the storm ends, to meet that availability requirement that you have to have. So if we had a storm situation, and if this was maybe a logic solver for an SIS, you wanted to make sure that not only would the logic solver be able to stand up to the storm, but it would be able to recover quickly, and during the storm it would still be able to function to make sure the safety controls were in place. We also look at the ability of the device to receive and ignore malformed packets in the correct protocol, because the protocol could be right, but there could be some nasty things hidden in the protocol, and you've got to make sure that the device can even though they receive it, they can still ignore it. And then the ability of the device to withstand any unicast storms on its interfaces. So from the network device, here we're looking at, again, the device's ability to withstand the broadcast, the unicast, and the multicast storms on its interfaces, and not to pass unwanted traffic to the end device. So that, again, it still passes control protocols, but it blocks anything else that it doesn't recognize or doesn't like. So, for example, here, if you're using firewalls, you've got to make sure the rule set is correct, and different firewalls obviously protect to different levels. Here again, if you were doing a comparison, that's another good way of looking at it, by doing running the scorecard on these particular devices. You're also looking at the ability to recover after the storm ends again, and the ability of the device to receive and ignore malformed packets. So even if the protocol is correct, you still want to make sure that you don't allow bad data or rogue control commands going through to the end device. So what is the value to the customer doing this? It's what I usually say, the so what. So what? What does this mean? Well, it gives the end user the opportunity to see how well the product conforms to the standard. And it also provides an ability to compare products. For example, if you're thinking of selecting different firewall manufacturers, that we could look at the different devices and see very quickly how well they compare. Manufacturers, from their point of view, they could also use this to demonstrate to the customer its products are moving towards compliance with 62443. Now, the reason we say that is obviously because, as I mentioned earlier, some parts of 62443 are released, but some parts are in draft. In providing this tool, we look at both because we're looking to determine the best practices. And at the end of the day, that's the whole point, is to get to best practice. The end user themselves can have confidence that the products being used are as secure as possible to the latest. And governing bodies will be satisfied that again, you've taken best practice approach to cybersecurity. So how would you interpret the results? Well, we basically split the report into sections that correspond to, again, each of the foundational requirements, as we mentioned earlier. Communication robustness requirements. Here we're looking at the different types of tests, the storm tests, the fuzz tests, etc. And the security development lifecycle requirements. So this is where you look at how well have the processes and procedures been followed, how well is the product designed from the cyber point of view. And then we use colors to indicate where the product meets or does not meet the requirements. Red, as I mentioned earlier, doesn't comply. Yellow, there is some compliance, and green, there is full compliance. So if we look at an example report, and I apologize, I'm trying to put these into the slides, so they have to be scrunched a little bit. But here, if we're looking at an example report for an embedded device, we would look first of all at the operating system, and in this particular device we're looking at has a Linux operating system. We document the version, and then you can see how the particular categories that we're looking at, and then we have a section for comments. So you can see red, the areas are red, the areas are green. So can the OS be patched? Yes, that's obviously a good thing from the point of view of patch management. Can programs be loaded or modified? No. And is the OS blocked from the user? No. So here again, when we create the report card, there are some formulas behind this to be able to look at combinations and to come up with yes or no or maybe in terms of the green, the red, and the yellow. If you look at the application protocol assessment, same thing. You can see areas of red, you can see areas of green. So very quickly you can see visually if a product is compliant or not under the various particular aspects that we're testing for. And USB connectivity here again, you see the product has USB ports. Well, it doesn't have USB ports, but it has two ports that it uses for a mouse and for a keyboard potentially. So that in itself could be a problem because it doesn't auto-run disable. The protocol fuzz tests, here you can see which protocols have we tested for, and again the results, you can see visually how well the product responded to those protocol fuzz tests. Development process analysis. This is where we talked about looking at how well have they developed the process, and you can see here there are some reds but mostly greens. We look at the documentation review here. You can see that there again a lot of reds, a couple of 2 or 3 yellows, and a green, which tends to suggest that the documentation review did not pass or did not do well. So that's an area that would be identified as being an area for improvement, for example. System integrity. Here are, if you're looking at protection against unauthorized changes to the software, there is no protection for that. So that would be a potential red flag because it means that somebody could come in and modify the software. Protects against unauthorized changes of data at rest. That is included, so that gets a green. Again, you can see quickly where are the areas that it complies, where are the areas it doesn't comply. And use control, same thing, authentication and data confidentiality. So these are some of the foundational requirements that we talked about and looking at. And then, for example, if we look at a network device, and here we're looking at 2 firewalls, and this is where you can do the comparison. We're looking at firewall A and firewall B. As you can see, looking at this very quickly, firewall B is a much better match than firewall A because it passes the correct traffic it needs to pass, it blocks the correct traffic it should be blocking, and it doesn't let some of the traffic pass. Whereas if you look at firewall device A, it does do some passing of traffic and some blocking, but it fails in certain areas. So this would be, if we were looking at choosing A or B, the obvious choice would be to choose B. So blocking, as we say, blocking unwanted traffic by the firewall is good, so that's what we're showing as green, and blocking the control protocol by the firewall is generally bad, so therefore it's red. Because what you want to do is you want to allow the protocol to pass through, but you want to make sure that bad commands or bad data is not passed through, so it can compromise the device. So that's from a network device point of view. Now, there are, within 62443, there are 3 areas that would apply to the system side of things. I mean, we talked about restricted data flow relates to zones and conduits. And so, of course, this depends on how well the control system network is laid out, how well it's partitioned, what particular zones have they created, are there DMZs incorporated and firewalls, etc. So that would also come into play. looking at timely response, as we mentioned, is all about processes and procedures. How well would people know, for example, in the plant, how would they respond to a cyber attack if that came through, or some potential cyber problem? So that's where the processes and procedures would need to be well documented. And we've actually worked with a number of customers, helping them develop policies and procedures on the cyber side, which covers all these areas. And resource availability, of course, is linked to how well the embedded and the network devices actually recover or handle the network storms. Now, this can apply to both products themselves and from the system point of view. So this is another area that we look at carefully to see how these are handled and how well they comply with the requirements. So the report will have sections on these particular areas too. So in summary, this report card provides a visual summary of a device's ability to comply with the standard. And so it includes, as I mentioned earlier, the 62443 portions that are released, but we're also looking at the unreleased portions to make sure we cover as much as possible. And it gives the end user a good feel for, okay, my network, my equipment on my network is robust enough, and I'm basically going to be able to handle most of the security issues that I'm likely to encounter, and the system will be able to still carry on doing its job. The end users themselves can get a quick evaluation of the integrity of the devices on the network. And also, as we mentioned, the manufacturers too can have this done. We can go in and we can do a report card for them on their devices, and it gives them more or less a gap analysis of where their product sits vis-a-vis the standard. So we can help with that. And we can also help with the areas that are of non-compliance and how to turn those around. And it provides a relatively low-cost approach because it's not a full-blown certification, and it gives a good indication of how the products will stand up, as I mentioned earlier. So from the end user's perspective, he can get a good feel for what's going on in the system. And we've actually done some work for end user customers where they've had manufacturers' systems on the floor, the shop floor, and they've asked us to come in and do an assessment. And this is a good approach to do that. So that, in essence, is the approach and methodology we've developed to give a visual indication. It's, as mentioned earlier, it's not a pass-fail. It's just showing areas that conform and areas that don't conform, and gives a good indication of the areas that need to be improved and adjusted. So I thank you for attending, and I'm happy to take any questions you have. Well, there is a question that's just come in about is this as good as the Achilles level 1 or 2? Well, the answer there is that the Achilles certification for level 1 or 2 is based on communication and robustness testing only. And so for the report card, we actually perform a short yet comprehensive version of communication robustness testing. But we also evaluate the product and development processes that, as we mentioned, are based on the 62443 standard. So it's more than just an Achilles type test. Okay, another question. How does this compare with ISA Secure? That's a good question. Well, the report card basically, as we mentioned, it's a quick, but it's a comprehensive evaluation of the product to the 62443 standards. But ISA Secure is actually an intensive certification scheme based on the standard. But the report card can be used, as we said earlier, as a bit of a gap analysis for those wishing to obtain ISA Secure certification. So this is not a replacement for ISA Secure, but it gives you a relatively low-cost way of doing a gap analysis. Because if you do go in and you do the secure testing, then it looks for everything. And if you fall down in one or two areas, then you will fail. And of course, you pay to have that work done. So it's important to understand that. And that's why we offer this as a sort of an in-between to help give some assessment, some indication. Okay. Okay, any more questions?